another conceptual question. Go ahead and decide what you think the answer is. Okay, the correct answer is C. So if we look at this 10 Newton force, the work here is 0. That's because the angle between these two is 90 degrees. We know work can be written as F delta S cosine theta. So even though the force is 10 newtons, we don't know what delta S is, but the problem tells us that it's the same in each case. Here they're calling it delta R instead of delta S. It still means the displacement. So in the case of the 10 Newton force, the angle's 90 degrees between those two vectors, which means we get a cosine of 90, which is 0. So no work at all done by the 10 Newton force. This 8 Newton force, the force is 8 delta R, I guess I can call it. And then the angle between these two is the cosine of 60. So we will have 8 cosine 60 times whatever delta R happens to be. The problem has told us the cosine of 60 is 1/2. So we essentially get 4, because 1/2 of 8 is 4, times the delta R. So that doesn't give us an actual value, but when we compare that to the 6 Newton force, the force is 6. Delta R is the same. We don't know the value, but that's okay. The angle here is 0 degrees. This is just 1, so the work here would be 6 times whatever delta R is. So having the 6 is bigger than having the 4. It was important that they told us the displacements were the same. So we don't need to know what delta R is to compare the work. If we wanted to actually come up with the numerical answer, of course, we would need to know what delta R was.